That works.
Hey everyone, welcome to the ARW discussion. Today's topic is going to be on tolerances. We got a couple new faces here. Uh-oh, somebody's got the YouTube up.
Nope, not me. Just check.
I don't think I do.
No, not me. Just check.
I'm checking here.
Echo.
All right, is that good? Nope. I'm checking here. All right, good. Nope.
I'll try muting. I don't think it's me.
I've muted just about everybody now.
Still got Mark. It's you, Billy.
It can't be me.
Billy, I think that was you. I think that was self-inflicted.
Yeah, not hearing it anymore.
Okay, can y'all hear me okay?
Yep.
You're 5x5.
What the heck's going on here?
Technology.
Yep. Well, we'll go with it for now. Anyway, I'm just going to mute everybody for the moment until I get through with this. All right. We'll go with it for now. Anyway. What the frack? I'm just going to mute everybody for the moment until I get through with this. All right. All right, guys, I got it figured out now. Okay, everybody good now?
Yep.
All right, I figured out what it was. Apparently, my YouTube I had an extra YouTube channel tab that was loaded up that was playing it on YouTube. I couldn't figure out what the heck was going on.
You got one hiding down on the toolbar somewhere?
Yeah, and I'm in full screen, so I didn't see it. So I'm going to unmute everybody now. I apologize about that. I'm better than that. I normally don't do that.
Hey, thanks for blaming us anyway, though.
Hey. Whatever. All right. Once again, welcome to the ARW discussion. And today we're going to be talking about tolerances. I'm glad you all had some tolerance there to deal with that little technical snafu. We've got some new faces today. We've got Giles with Let's Roger That. And then we've got, let's see, who else here? We got Pete with Pete Rondo. Is that right, Pete?
Yep, that's correct.
All right. That's our new folks. The rest of these guys you've seen at least once before, hopefully. Jeff is rather new, and everybody else is pretty much regulars at this point. So I'm going to open up the floor here to the panel to see who wants to go first on talking about the tolerances and fitment and that kind of stuff. Actually, I'm going to pick on you, Stuart, since this was your topic. You get to go first.
All right. Yeah. No, that's fine. So I teach in my local community college, and I always tell my students, you gotta realize what good enough means. You know, it doesn't pay at all to make things more accurate than they need to be. And I've had a lot of students who, no matter what, they wanted to make everything to plus or minus half a thousandth. And if you've got something that's a clearance hole for a bolt, it doesn't make any sense to have a super tight tolerance, especially when misalignments might occur, and having a really tight tolerance might actually work against you. We've rebuilt a lot of pumps at work, like large 12-foot long sump pumps, big pedestal pumps, and they'll have bronze bushings on the inside. The outside of that bronze bushing has to be very tight, inch and a quarter, whatever, press fit into the casting. The inside of that bushing, though, is usually plus 10 thousandths or maybe even 15 thousandths on the larger ones, because by the time you actually bolt all that stuff together and you've got welded on flanges on these pipes, any misalignment causes the shaft to bind up. Another story that I've got, this one came from my buddy Destin. He used to work in the physics shop on campus, and this is at the University of Illinois. And someone came in, and they had an angle specified on a part, and it had a tolerance of plus or minus 5 seconds, and he's sitting there scratching his head going, how the hell are they going to measure this? And so he finally said, hey, how are you measuring this plus or minus 5 seconds angle? And they're like, oh, that angle, that doesn't matter at all. It's like, then why did you put it at plus or minus 5 seconds? Or the same thing, you'll get plus or minus 2/10 on a lot of things. And if you put those tolerances on a print and bring it to a shop, then they'll make it to that tolerance. It's just going to cost you a lot more to do it. So think about the purpose of the part. If it's something that is that's going to be just hanging out in space, not touching anything, it doesn't need to have a tight tolerance. There's no reason for it whatsoever. Save the really tight tolerances for bearing fits and press fits and things like that. That's about all I've got.
All right. Who's up next? Who do I get to pick on? Mark?
I'll go for it.
All right. Let me get you up here. There you go.
Yeah, I really, tolerances have a lot to do with your equipment capability, but what Stuart was saying, I used to design machinery or machine improvements for the printing industry where I work, not the industry, but I would always get the machinist involved with what the application was, because he'd look at the print and I guess my prints, my CAD ability was not the best, and I didn't specify plus and minus, and they'd come up with a perfect part when it wasn't necessary. So I don't know, like Stuart was saying, about the only thing that is really high tolerance that I do is maybe a thread fit, and that's really not high tolerance, but a bearing fit or a sleeve bearing where you got to maintain a film of oil. But most things are not really that high tolerance. I think machinists in general kind of obsess about high tolerance, probably overly so. But maybe I'm not a machinist.
No.
I don't obsess over it. I try to obsess where it matters, like a bearing fit. Anyway, that's all I got.
Yeah, what is it they say? You can have it cheap, you can have it accurate, and you can have it quick. Pick two of the three, right?
Yeah.
Yeah.
I've got some thoughts.
All right.
For me, I sort of have two modes of operation in general. Because I'm a novice machinist, I normally, when I'm doing a project for myself, I shoot for a lot higher tolerances than anything ever requires, because it's simply hard to do, and it's the skill that's really hard to acquire. So, sorry, I shoot for that first. But my other mode of operation is when I'm doing projects for an outside company or vendor, then I follow their sheets, and especially if there's time frame involved where they need it delivered on time, then I tend to follow what they require more closely rather than shoot for the highest tolerance I can manage. So I mean, that's just sort of my 2 cents. I mean, as a novice, it's easy to get a part rough, but it's pretty hard to get it accurate, especially extremely accurate. So 2 cents.
All right.
If you've got just moving that decimal place over 1 point is gonna increase the cost of the part. And when you're talking about just shafting and things like that, might be the difference between turning a shaft and actually having to put it on a cylindrical grinder and grind the shaft. But as soon as you move that decimal place over 1 point, it adds a lot to the setup and the labor and everything else. A lot of guys that draw these, they either don't put any tolerances on them or they put unneeded tolerances. I mean, this kind of just drives home what Stuart said. So, those are my thoughts on it. And there's a really good section of machineries about sliding fits, press fits, based on the diameter of the part and things like that. I always use that as a point of reference. And I've had some tricky ones, like some very thin wall tubing that has to be pressed into a bushing, and they want it to be a very tight fit. But it's small. The tubing that goes in is only 1/4 inch OD. And it's a very thin wall, and with a 1/2 thousandths interference. But the tubing's so thin, you go to press it in, you just destroy the tubing. So you have to do a hot-cold assembly to even make it work at all, to get it to go together. But machineries is a good reference source for tolerances. If we could get the engineers to read it, it'd be even better.
So what you were saying about distorting the tubing, small bearings, the little miniature bearings, man, if you get those like a 1/2 thousandth too tight, they just don't turn.
Yeah.
They're hard to deal with.
I like this. I like what Dennis is saying right here. Absolutely. Could not agree more with that statement right there. I've had a hard time hitting tolerances on bearing bits. Just about every time I try to hit one, I almost always blow it. One technique I picked up using a boring head was you can actually speed the boring head up just a little bit, and the centrifugal force will sling that boring bar out just a little bit more if you just need to shave a couple tenths off to get your fit. I don't know how many other people do that, but I found that to be
neat idea.
Huh?
Neat idea.
Yeah, it seems to work a little bit. I mean, granted, I'm using most of my stuff has been on aluminum. I don't know how well that would work on steel and stuff, but when I was doing the robots and stuff, that's what I was doing. Is I get it close, and then instead of trying to mess with the fiddly screw, I would just crank it up an extra couple hundred RPM, and then go back down, and it would take off just a little bit more, and then I'd get my fit that I was looking for.
Probably changing the way it cuts too.
It does, and like I said, with it, boring bar that long, it just a little bit more RPM just adds a little bit more force on that, and it seems to open it up just a little bit more. I don't know if that's an actual true technique or not, but it seems to work for me.
I actually just got hosed on a nice tight tolerance. I was going for a press fit on this tabletop build that I'm doing right now, which I still haven't finished that video. And took a spring pass, and I shouldn't have. So it ended up, it was snug, but it was, I ended up having to Loctite it and hold it with a set screw. So you guys will see that in the video. But generally when I'm using a boring head, I want to take 4 or 5 finish passes. I want to know exactly how that bar is behaving with that cut. So if I'm 20 thousandths away, I'll take 5 and then a measurement, 5 and then a measurement, because I want to know exactly what it's doing. And of course, the last pass always screws up.
Yeah. I think it was Stefan was describing a technique where you once you get close there, you take your cut and you divide that by 2, and you take your next cut, and then the last cut you go for it. You only do that so many times. If I remember correctly, this has been 6-7 months ago since I watched that video. I have to go back and watch it again. That was some good advice. Always get a little nervous on the lathe trying to hit those dimensions because
it is, and it's cause and effect and action and reaction. You may have called for 5 thousandths, but did you get 5 thousandths? And you may have called for 2.5 thousandths. Did you actually get 2.5 thousandths? So it's all cause and effect.
Yeah.
That's
where
what I just get a strip of emery cloth, and when I'm a half a thousandth or a thousandth of where I need to be, the emery cloth does the trick.
Well, I learned a neat trick. I learned a pretty neat trick from Renzetti. He was, I've got my reamers that I buy for very specific jobs, and I had one that was running a little heavy, and I needed it just a tad smaller. And I made a little aluminum lap, and I chucked the reamer up in the lathe, and I made a little aluminum lap, kind of a pinch type, and I charged it with a diamond paste, and you run the reamer backwards and just slide that lap across there. And I shaved a couple of tenths off of that reamer, just to give me the fit that I was looking for that specific job. And it was the greatest advice. And he did a little video on it, and he referred me. It was several years old, and he referred me to that video. And I, as soon as you see it, you got it, But you can dial in your reamers if you have reamers for a very specific job.
Oh yeah, that's a good idea.
The reamers have been my hard part. Doing some 1/8 inch pins and stuff like that. I don't know what's going on, but I get these reamers are supposed to be, a half a tenth undersize or something like that, and that they almost always come out where the pin is not a press fit. It's almost always slip fit. So I don't know if I'm getting cheap reamers, or I've got terrible run out with with what I'm using, or what the deal is. I need to go back and look at it.
Well, everything matters, even the temperature of your part. If you just got done center drilling, and now you're coming back on it with a reamer and your part's hot, you ream it, pull it out of there, part cools down, shrinks up, now you're too tight. Everything matters.
Yeah, I think cheap reamers are not real accurate too.
Yeah, go ahead, Jill.
You mentioned Stefan, and when it comes to high tolerances, trying to get a nice press fit, I watched one of his videos where he explained that using different cutting oil will actually have an impact on the amount of material that you'll take off. So, for example, he was talking about cutting oil versus that white spray lubricant, that cooling agent that some people use, and it was recommended that you'd use that cooling agent versus, say, the cutting oil, and then you would probably, in all likelihood, it would help you achieve the tolerance that you required. And he actually showed that in his video, and I thought that to be rather insightful. So when I actually try to achieve a very precise measurements, especially in the mill, I will use that technique, and it works for me so far. It was a really insightful tip that he gave there.
Interesting.
Yeah.
RPM also plays a big part.
Yeah. Half the speed, double the feed of a similarly sized drill.
Yeah.
And,
Rico's saying oil for steel and coolant for aluminum. I personally like using diesel or kerosene for aluminum.
Yeah. Seems like something we should all test out, and all 9 of us come up with the exact same video at the exact same time.
Great idea.
2 Mondays from now, I guess. I don't know.
I usually use a lot of oil on reamers,
With
but maybe
9 different results.
Yeah, exactly.
Well, I mean, the one thing that that Stefan mentioned is that he didn't know the exact reason for that to happen, and I would imagine that there's something to deal with the viscosity of the liquid and how it deals with heat dissipation and whatnot. So I don't know, we'd have perhaps an engineer, if there was an engineer in the group there, that might be able to explain that particular thing.
could be sliding versus cutting. I think that's why the lighter weight oil works better on aluminum.
Yeah.
My biggest issue has always been chip welding with aluminum. That's why I went with the diesels or the kerosenes. That's what I'm trying to prevent more than anything, is that stupid chip weld.
That's something I don't machine much of, aluminum, so I'm not really much of an expert on that.
Um, 2 or 3 flute cutters, this or the kerosene, or if you really want to pay, use WD-40. I know some people like the using that because it smells differently. I've seemed to have good results with it.
CRC Power Lube works fine. That's CRC's answer to WD.
Is it?
Yeah.
Is it true that the that stuff that you sell, I don't remember the anchor lube, does that cause issues with aluminum?
No. You
No.
can actually, it's water based, so you can water it down if you wanted to.
Okay, I thought there was something that it stained. It would stain if you left it on too long.
If you leave it on cast iron overnight, it'll turn it dark.
Okay, that's what it was. Okay, I couldn't remember. And there's some coolants too that will interact with aluminum too, so you got to be careful what you're using. I do know that there's some that will absolutely stain aluminum.
We do a lot of so the self-drilling, self-tapping screws into structural steel, big heavy I-beams and big heavy channels and things like that. And the thing with the anchor lube is it's thick, and you can actually pre-charge a whole batch of screws. We'll just sit there on the bench and put a blob on the tip of each screw and just stack them up overnight. And you can let them sit overnight; it can completely dry out. And the next day, it's kind of like like soap almost on each one. It works fine, but the guys can just grab screws and go to town. And we cut these screws are almost $1 a piece that we use into the structural iron, and it saves from drilling failures and threading failures. Broken screws are a pain when you got to stop and drill out a screw. So running those screws dry is horrible. So that's the big advantage to anchor lube. Okay. We use it in the field all the time. It doesn't make a mess. Just wipe it up, clean it with water. You didn't have to go full screen for that.
Yeah. Somebody's making a loud noise there. Who hasn't gone yet? I don't think we heard from Pete, Jeff, or Everett. You guys want to talk?
I'll go.
All right. Get you
so I don't do a lot of high tolerance stuff, and if you're going to give me a drawing and say, make this part to this tolerance, plus or minus whatever, that by itself, I can, usually hit that close. And if I can't, that's a lack of skill. But the other issue is just if I am just designing something of my own, or if I'm trying to restore something where I don't have original specs on it, so I don't know what it was originally supposed to be, that's where I run into trouble, because I am guilty of trying to make everything just way too precision when I hit stuff like that. And that extends to everything from, doing something on the lathe or, trying to build a wall, remodeling the house. It always seems like I'm trying to hit something that I don't need to be hitting. So I'm very guilty of that. But yeah, so that's about my take on it. I know what my personal limitations are, and I can't seem to get around it sometimes.
Well, someone told me a long time ago that left up to their own devices, machinists will always make things too tight.
Well, I mean, going along with that, at least if I have it too tight, then I realize it's too tight, and I still have material there that I can take away. So I suppose that's better than the alternative where it's already too loose, and no matter how many more times I cut it, it's not going to get tighter.
There's a lot of truth there.
Yep. Okay, I just got a comment on the pick and place machine sitting there behind you.
Yes. Yeah.
That's pretty cool, with a smiley face or with the googly eyes on it.
The googly eyes, yeah.
Yep.
Yep.
So you know where you stand with it?
What is that?
It picks and places surface mount components for electronics. Really nice to have. Looks like a fairly decent size one too.
Yeah, the whole front of this shop is basically designed for the products that I build in house here. So everything in here, from the CNC machine, is for machining electronic enclosures, to the pick and place machine, to the reflow oven that's down there. The other room is where the lathe and the mill and that stuff is, but out here is kind of my office area and also where I keep the pick and place machine.
Cool.
Nice.
All right. Jeff,
Very nice.
Everett.
Well, I'm just I'd have to piggyback on what Stuart said as far as knowing what the tolerances are. I'm just just a guy playing around in his shop, in his garage. So I don't do it for work. I don't. I just kind of go out there to have fun. So most of the stuff that I'm doing is I'm restoring a bandsaw, and I need to make a part for it or something like that. But occasionally I'll have friends will have something that needs done. And I remember a buddy of mine, he was doing, what was he doing? He was making these stainless steel sleeves for a guy, and he needed 50 of them. And his 10EE was too small to do it, so he asked me to do it. And I'm trying to get it the exact number, and I'm finally looked at that plus and minus, and it was like plus and minus 5 thousandths or something. After that, I was boring it out in 3 passes and chucking in the next piece, and it went a lot faster. So that's I don't really do a whole lot of tight tolerance. It's usually, hey, that's good enough, that's close enough.
All right. Well, I'm going to take a break here for just a minute. I think Stan has something he wants to talk about.
Oh, I will talk about it. We've got this coming up. If you've got any questions on this, the Barzy Summer Bash coming up in June, I'll be happy to answer them if I know the answer. I'm running very late. I usually try to announce in February, but I haven't had time to open registration. We are working on it behind the scenes. We haven't really made it public yet. It is June 24th, 25th, and 26th in Southern California. Like I say, I'm not ready to take registration, but I will answer some emails. If you want to send an email, it's not my general dump email box. It's summerbash@barzyindustrial.com. For those of you that are repeat offenders and want to return, you're on my safe list in the email, and I do go through my junk folder in that email box every day. We're going to have meet and greet and swap meet on 24th. 25th is Saturday. That's our main event. That's when we're going to hold our raffle. And 26th is just kind of a casual day, like another meet and greet. We've got some of the usual faces that show up for sponsorship. This year we are not sponsored by American Rotary. We are sponsored by the Hot Shot Oven and Kiln Company.
Nice.
I've got a pretty good working relationship with them, and amazingly enough, I know a guy. So the Hot Shot Kiln Company is sponsoring the main event. Our raffle is brought to you by Shar's Tool, and they're a main sponsor for that. And I've got some other sponsors that are coming along. And, I'm not ready to announce. I'm working on my list for the guest hosts, which, a few of them are, Keith Finner and Tom Lipton and Chuck Bomarito and Ray from Ray's Garage, and some of the usual faces, but I'm not ready to announce that complete list yet. I just wanted everyone to know that I am running late this year. I'm extremely busy at work, and I appreciate everyone's patience during this time. And but we are going to put on a pretty good event. We're going to have guest hosts behind the microphone on Saturday. We're going to have a few there. Dale Derry's still my main producer for that. I'd like to thank the camera crew. Brian McGrew and his whole clan does a great job every year. And we're working through our sound problems that we had last year. We have to broadcast, excuse me. We have to broadcast to an audience, which is live there, but we also have to broadcast to YouTube. And we were having some sound issues last year that couldn't be overcome with the equipment that we had. And that's been fixed, I've been told, for this year.
Good deal.
Yep. Yeah. And if anyone's got any questions, Billy, if you throw them up on the screen, I'll be happy to answer them.
Rustanox there is asking, are Europeans welcome?
Are Europeans also welcome? Of course they are. If you can get here, you're more than welcome, Rusty. No, we've had some internationals. I don't know what they're doing over in Australia, whether they're still on lockdown or what they're doing over there. But I know that some of their travel was restricted. We're living in strange times. Our COVID policy is if you're sick, don't show up. I had Corona right at New Year's. I was only down 3 days, but after my quarantine, we lost 9 total. And the entire Bar Z crew got sick, and we caught it from our customer over in Hollister, California. So Bar Z was out of business for 9 days. But like I say, just use your head. If you're sick, don't show up.
Yeah.
And, we're not going to require immunization reports or a passport or any of that stuff.
Well, good deal.
Yep.
Wished I could come. Already did my trip for the year.
Yeah, I try to limit. I did 2 trips last year, which was more than my share. I wanted to get out to Flywheelers. It looked like you guys had a pretty good time.
We did.
I've just been too damn busy.
Yeah, lots of fun. Fairly, given that it was in February, we're still kind of hot down in Florida. I did get a little bit of a sun burn on me. But
Did Steve Summers go down there?
I did not see Steve. No, he was not down there.
Okay.
Right.
Yeah, we've got. Let's see who's here. Okay, well, we got Dudley Toolwright. He comes every year.
Yeah,
he always comes a week ahead of time and helps me out in the shop. Robert, I sure appreciate everything you do every year.
I'm willing to do it
All
again.
you other guys are invited too. If you guys can make it out to SoCal, we'd love to see you.
I've been there the last 2 or 3 years, and it's a blast every time.
Who was that?
That was Jeff, another machine.
Oh, do you come down?
Yeah, I don't know. My daughter swam in your pool that one year.
Okay.
Years ago. Yeah.
Okay. You're kind of a Tom Lipton lookalike there.
Well, when I had the mask on, your wife thought I looked like Brad.
Brad Jacobs, maybe.
When I
Okay.
wore the mask, yeah.
Yeah, I can see it. Well, that's good. I hope you enjoy yourself when you come. Take your mask off this year if you want to, and introduce yourself. I don't get. I'm going 1,000,000 miles an hour that day, and I don't get to mingle like I probably should.
I'll throw that one out.
Everett, Canadians are welcome too. You're more than welcome to come on down, Everett.
I'd
Get
love
them
to.
truck drivers out of your way and come on down.
I'd love to come down. Like I say, it just all depends on various different things. Like I say, it sounds like our feds have loosened up a little bit about actually letting us back in the border without getting, zipped up 6 ways from Tuesday. But
Right.
As far as getting there, it all depends on family scheduling stuff. Like my wife works shift work; she has to put in for vacation. Half the time she doesn't get it. Stuff like that, and now fuel's like, fuel is now a bit of a concern if I were to drive. And for it, like I said, I'm gonna try. I just can't promise anything. I'd love to.
Okay. It's a pretty good time.
I know. I'd love to.
Rico asked, "What are the dates again?" Okay, it's gonna be June 24th, 25th, and 26th. That is the weekend after Father's Day, and it is the weekend after summer solstice, which is the first official day of summer. So that's why we call it the Bar Z Summer Bash. We always celebrate the arrival of summer. And I've actually personally been doing it now 22 years.
Wow.
But this is our 7th year for YouTube. So if you'll notice our logo says Bash number 7. So that's why we picked that Jack Daniels label for this year.
That's pretty impressive. You've been doing it that long.
Yep.
Well, it was
Hats
just
off.
all it was Customer Appreciation Day.
Okay.
We always had a little raffle and stuff. And then when YouTube got sucked into it, my customers kind of got shoved back to the back burner. And Summer Bash just grew a persona of its own. It got to where I couldn't even handle it anymore. And I mean, I really rely on all the other YouTubers that come and help and, you know, be a guest MC or hold an event or run the swamp meet or just everything, you know, that you guys are awesome when you show up. And then, you know, Summer Bash is the only time my shop sink gets cleaned. Ray Cornelia comes over and takes one look at my sink and goes, "That's disgusting," and he cleans my sink for me. That's the only time my sink gets cleaned in the shop. You know, so I mean, everyone helps out in some way, and it's a load off of me. It would just be too overwhelming. I couldn't handle it by myself.
Yeah. I'm glad you put it on. One of these days I'll make it down there, and I'm sure some of the rest of us will too.
Well,
Yes,
I mean,
indeed.
just turn it into an annual migration, you know.
I might be there. I wanted to get to that part of the country anyway.
Yeah.
I grew up on the West Coast, but I've never been to that area.
Yeah.
Some
I've
of us
been to California a few times, San Francisco and San Mateo, but I don't think I've been to Southern California.
I
Go ahead.
sorry, guys. I just hate to divert the topic, but before I forget, I should mention that Blondie Hacks, Quinn at Blondie Hacks, has an absolutely fantastic video on fits and tolerances. And I think that any viewer out there that really has a difficult time understanding that whole topic should watch that video. Yeah, sure, you can read the machinery handbook and confuse yourself to death. But if you watch her 20-minute video, it's going to give you a really great understanding of what are fits and clearances and tolerances. She'll give you the references from the machinery handbook, but won't confuse you with them. And I mean, granted, I've only been at this for about a year now, but it was clear. Truly, she cleared everything up for any beginner out there. And I thought it was a really great way. Well, we're obviously promoting her channel, which is fantastic. But it gives you perspective on, it's like Stuart was saying earlier, don't make it too tight if you don't need to. And she gives it perspective with, she was using some sort of drill rod, whatnot, and then creating various holes and making it fit, and referring to the various sections of the machinery handbook, and explaining the variants and tolerances that are listed in this chart right here. That's something that I think Pete was mentioning and Jeff earlier, that we have a tendency to try to make things way too precise. And I mean, there's times for precision and there's times not to have it for all kinds of different reasons, whether, you're looking at say you're a project manager. I have been in the past with many employees, and you have to understand the project management triangle, which is quality, time, and budget. And any changes on either one of those parts of the triangle will affect the other. And but as for me, I'm doing this because I'm retired and I'm having fun. But it's still true in the overall perspective of how to apply these tolerances. Something else that I thought I should mention is that when you're talking about tolerances, you need to consider, well, of course, what you are doing, the materials you're going to be using. Will there be movement between the various materials, because that will affect wear, as well as, because fit, if it's too tight, it'll wear more. Think of a piston and the cylinder, for example. There's a tolerance there in between those two, and the rings cover the rest. And of course, the materials that you use to interact against one another are built to take those pressures and wearability. So that's something that's interesting to note for beginners that are out there. Think about the materials that you're going to use. Actually, Mark and I had a really great discussion all day yesterday. Throughout the day, we're talking about, this parting tool that I'm developing, and this is a prototype. But we started talking about the various types of steel and the tolerances that I'm using in my tool creation, and the tolerances has a huge effect. Now I may. Because in the end, I'll probably end up using a different type of alloy, something like 4140, which will have more strength and flexibility to come back to its original shape as it flexes from the cutting forces. But those are all the things that you need to think about when you're talking about fits and tolerances. Stuart, you might bring some more insight on that because you're really well versed on those things. Perhaps you could come into this discussion.
Well, I don't know about that. I mean, as far as fits and tolerances go, it really all depends on function. If it needs to be a press fit, then make it a press fit, and that depends a lot on size too. That's something that they cover a lot in Machinery's Handbook, and in general, everyone's like, "Oh, just make it a thousandths oversized or undersized, depending on which part you're making." But if you've got a really big part, that's a lot of contact. I was doing something not too long ago that's 3/4 of an inch in diameter, and if you tried to do a thousandth undersize, it would just gall together, and it wouldn't actually press all the way in. So the larger your part, the tighter it's actually going to be. And likewise, what Stan was saying about that 1/4 inch tubing, it depends on your part's flexibility as well. And then in plastics, for instance, if you need to press something into plastics, it's so easily deformed. You actually have to have quite a lot more interference. Otherwise, the thing will just pull straight out. It really depends on, well, it's like any other thing in machining. The answer is it depends. The size is the big thing. The length of the engagement, if it's something that's 4 inches long and you've got to press it in, if it's a piece of tubing that's going to get crushed, you've got a lot of variables in there.
Yeah, I've got a project coming up where I've got to press. I got to press this in. It's a 2-inch ID, and then I've got another one in the other room that's 3 3/4 ID. So they're both, and I basically got one shot at doing it right, or I screw the whole thing up.
Yeah. I was doing a project a couple months ago where I was pressing in a 3/4 inch aluminum rod into a piece of flat stock, about a 1/2 inch thick, and I didn't get the tolerances right, and ended up blowing a chunk of the aluminum on the flat plate. It galled up on me and ended up bulging it on the other side of the plate as I was using the press to press it in. Two types of tolerances, and the material makes a difference. The aluminum will gall with will gall on itself really bad. I'm pretty sure it kind of welded itself. It was so tight.
That whole price, speed, and quality ratio, that's all been kicked out the window now because everything is slow and expensive. So the only thing that's variable is the quality at this point.
Yeah.
That's a good point.
Well, Stuart touched on something on depending on your material that you're using. If you are using a plastic, maybe a Teflon or a UHMW or something like that, when it comes to threading, there's different classes of taps you can get to do your threading, and you'll end up way undersized to slightly undersized to right on spec to oversized even. So depending on what's going to happen to your part during its service life, how it gets assembled, how often it gets disassembled, and if it's going to get heat treated, whatever, you're going to have to probably buy the correct tap for your application. I know in the Teflon we have to get really, really undersized taps to make that stuff work. That Teflon is just so buttery.
Yeah, I got questions at some point for people doing heat treating and tapping and thread classes and stuff. I just always went with the standard Starrett tap chart for my thread sizes and use standard off-the-shelf taps. But what do you do when you heat treat? because you have to pre-tap those holes and then you send it off to heat treat.
And then when you bring it back, I usually chase them when they come back. You can chase the threads, get all the scale and stuff out of there. They'll be scaly.
And
But,
anytime you're doing anything,
don't go undersize.
Yeah.
If anything, I think there's 4 or 5 per thread. There's 4 or 5 different sizes of taps for all the different class of fits. Check machineries; it's all in there.
yeah, with taps,
Either go right on size or slightly over.
Yep.
with taps, they've got that ground thread limit. It'll say H3 or H4 or something like that.
Yep.
And that's how many was it half thousandths oversize it is. So a H3 would be 1,000th and a half oversized. So I'm just pulling that out of my butt. I think that's right, but I'll have to look it up. But yeah, if you're doing stuff in tool steel as well, something that's going to get heat treated, go with a 50% thread depth. There is no reason to go with that standard tap drill chart, which is about 75% thread depth.
That's a good way to break taps too.
Yeah, it is.
Yeah.
So anytime I do anything in tool steel or if I do anything in stainless, I go with 50% thread depth. And actually, I was making some stuff out of 1045 yesterday, and that was being a bit of a pain in the butt to tap as well, which it usually isn't. I guess my tap was getting a little dull there, but I ended up going with 50% threads in that too. The simple math there, I cover it in one of my videos on threads and taps and dies. To get a 75% thread, which is what you see on that tap drill chart, the simple math is major diameter minus pitch equals your tap drill size. So with inch threads, you have to figure out what your pitch is first. So that's going to be 1 divided by your TPI. So if you've got a quarter 20, 1 divided by 20 is 50 thousandths. And then you take 250 minus 50 thousandths and you get a tap drill size of 200, which you look at that, that's your number 7 drill, which is 201. So in order to get your 50% thread depth, if that's giving you 75% thread, then you do major diameter minus, in parentheses, pitch times 0.66. So that'll take a smidge off of your pitch there, and that should give you roughly 50% thread depth.
Yeah.
And then the other thing there is thread forming taps. If you're using brass or aluminum, or you can use thread forming taps in most anything, but generally softer metals, you have to have a bigger thread tap drill for that, because what you're doing, imagine you're squeezing Play-Doh in your fingers and you get Play-Doh squeezing out from in between. You're displacing metal with a thread forming tap. So you have to have a larger tap drill in order to give room for that material to squish inwards in the hole.
Right.
It'd be
I
almost like
discovered that equation a few years ago for figuring out your tap drill size, and I was so shocked that it worked that easily that I had to go and calculate a bunch of them just to prove to myself that it actually did work from the chart.
Yeah, and it works for inch and metric too. So great for the rest of the world. Of course, metric is so much easier because the pitch is right there in the specification, the M6x1, for instance. We just have
Push arm Russ
there
Knox.
TPI.
Yeah.
So Stuart, you're saying, like, I've never used those thread forming taps that actually displace the metal. It almost sounds like it'd be a similar process or idea to like knurling. Now, crazy thought just went through my head. Have you ever used one of those because your hole was a little bit too big and you had to put a pin in it and just use it to basically knurl the inside of a hole?
No, I've never used it like that.
Okay.
I remember the first time that I tried to tap with one, and I didn't realize I needed a larger hole. And a 632, which is already the most likely tap to break, and it was in brass, and I jammed that sucker in there, and somehow I didn't break it. I don't know how I didn't. but I did some quick Googling and found out I was supposed to drill a bigger hole for it. Yeah.
Well, Everett, you've not talked much on your tolerances. I know you have tolerances you can deal with all your automotive work. So, you want
well, okay. As far as when you're dealing with engine parts, you got an engine apart. It either is, you measure your bearing clearances and such, and you use your plastic gauge. And if that journal is too big, then you have big issues, and it gets expensive for a customer. But a lot of the stuff I do at home, as far as when I was working at the truck shop, I sometimes brought stuff home to fix or fiddler with or whatever, just to get a guy on the road. But a lot of the time, what I have is I actually have either the broken parts themselves just to measure right off of, or the part that pieces got to fit into, right? So, and again, it depends on the application. I didn't really add much because pretty much everybody who spoke ahead of me covered kind of how I approach things too. The only thing is, as far as tolerances for my own projects and my own messing around in the shop, if I'm making my own little tool for myself or whatever, I will admit sometimes I probably take too long at it because I'm trying to practice getting on, like within a half a thou. Between my skill set and the equipment I have, it's not all the time. Let's just put it that way. But I do try to practice it so I still have that there. I'm a little out of practice right now because I haven't actually turned on a machine in a year. But as far as that's often what I do just for myself, just for practice. But I'm also out there having fun. If it was something like I say, there have been a number of times I came home during the day, and I actually got to, I was still on the clock for my buddy, but working in my home shop, fixing something, putting something together, take back to the truck shop. Your time is money, right? So you're trying to get it done. Just, okay, this will fit, it'll work, done, I'm out the door. But yeah, I try to tolerate. It's not that I don't care about tolerances. It's just if I'm in a hurry, I pick the ones that matter. If I'm doing my own thing, I try to practice so I improve my skill set. That's pretty much everybody else has covered how, a lot of what I think about it too. So I didn't really have much to add.
That's all right. I wanted to hear from you anyway.
So
you have that broken part, Everett. When you're trying to copy a broken part, then you tend to try to make it exact, whereas that broken part was made within certain tolerances, and you don't know what those tolerances were.
Exactly. We don't have access to the original drawings.
Yeah.
And sometimes it's been actually, something spun or it got buggered up or whatever. So then you go, okay, I got to put this bearing on this shaft, which has now been worn 10 under. All right, well, what's a standard bearing fit? And then you go back to the book, and go from there.
Cool. A couple things I want to talk about. Number one, be sure to click the like on this stream. Let's get those like counts up there. Another thing, I know some of you are going to groan when I say this, but we have opened up a Facebook group to help get more topics and introduce more machinists to the stream and get more people on here. We want to promote some of the smaller guys. YouTube is really hard to get traction on these days, and we're trying to promote some of the smaller and newer YouTube machinists. So anytime we have some of these guys on here, please be sure to go to their channel, subscribe and like, and do all the things, the YouTube things that you normally do. If you've got a YouTuber that you like that's not been on the show, pester them to give us contact and see if we can get them on here and get them into the panel. That's all I got to say for that. So I'm going to back out now, and we'll keep talking.
Billy, you're just a regular Johnny Carson. You know that? No, you're doing good.
We're dating ourselves here.
Yeah, a little bit.
You reset your DRO there, Billy?
I did that in the Aussie edition. Unfortunately, apparently Stan wasn't watching when I did it.
I'm sorry.
But you can go back and watch it. What's the name of the Facebook group? That's the ARW Discussion Cafe, I believe is what I named it. I'll put a link out to it, or next discussion I'll actually have a name of it up. And I think it's private at the moment. I'm going to have to open it up to the public, but I'll get that taken care of.
What is your intent for that group? Is it panel members only or everybody?
It's a mix. I want panel members and community in there to help promote the discussion, help us pick topics, ask questions, just expand the community base outside of the chat channel here, just so that we have a little more interaction with everybody, and make it a little easier on the people running this, so that we can get the content creators on here and not fumble around like I did this weekend and send you all emails Friday night saying, hey, I need people on the channel, and I don't even know what our topic is. Some of the stuff that Harold had problems with in the past.
So are you moderator for that group, or?
I'm the admin, and DJ with Foxburgs is also the moderator for it.
I mean, you just need to set yourself some policies, what you're doing with the group. I've moderated a lot of really big groups. And if you tell them no advertising, some people will come in there with the intent just to advertise the group, because you've rounded up a very targeted audience, and that's very appealing to a lot of people.
Yeah.
So if you've got a no advertising policy, you're gonna have to kick some people out. You can't always be a nice guy. You just gotta get it done.
Somebody's saying keep it private. Yeah, right now it's private. Maybe I need to think on making it public for a minute. Maybe I can just put the YouTube channel here, or the Facebook group on here.
The troublemakers are easy to spot, and if they're not right away, they'll eventually reveal themselves. It's not too hard. Take you maybe an hour a week to weed through everything.
Yeah. Well, looks like we got about 4 minutes left. What's everybody working on lately? I know what Mark's been working on. He's been doing die holders lately.
Yeah.
And
I've been
just
trying
watched
to
the video, Robert, on friction welding.
Oh yeah. I saw a really cool video on that from another guy, which I can't remember his name. Unfortunately, I want to give him credit, but he was making rings, and he was using dissimilar metals. So I thought I'd give it a shot, and it was pretty interesting.
You do it on the lathe?
Yeah, I did on a lathe. The thing I hate about it is I had to use my brake, and so
I was confused about that. Why are you so concerned about the brake?
Well, because you have to stop it hard and fast. So I did it purposely not using my chuck, because I didn't want that extra mass sitting on the bearings, because you're stopping everything, and all those gears, the brake is attached on mine on the motor. So when I hit stop, then the belts and all the gear train has to stop, and that mass on the end, which would have been the chuck if I'd had it, would try and keep moving. That's a lot of force. So I was sort of leery about it. That's why I did it with the 5C collets, just to minimize that mass. But still, it kind of made me cringe each time.
You still hear the backlash.
Yeah, mine's got a caliper style brake on it, and instead of a strap. And I've stopped it at 2,000 RPM with a 6-inch 3-jaw. It doesn't stop instantly, but it does. I guess the brake material is a little worn, but it does stop within about 2 to 3 seconds.
Yeah, it's pretty fast. I was just worried about the gears and everything connecting the mass to the drive.
I tried some friction drilling. That was successful in some some tubing that was kind of thin, and it added enough material into the tubing that gave me some place to put some threads.
Yeah, I was gonna.
That's a cool video.
Yeah, I mean, you buy the bits and stick it in the mill, run it up as high as it'll go, and drill your holes. And it just displaces a bunch of molten metal down inside the tubing. And
you mean that right there?
Never heard of that.
Yeah.
Yeah, I've seen some cool videos. It's solid bit, kind of pointed, and just run it really fast. And
it's got a little funnel at the base of it to kind of push all that hot metal down. Solid carbide. You could probably make them. They're not that complicated.
And then you use the thread forming taps instead of a standard tap, and you don't lose any material that way.
Tapered tap. The ones I was doing was 3/8, 16. But the tubing was so thin, you wouldn't even get one full thread in there. But after you run a friction drill in there, it displaced so much material down in the hole. You had plenty of room to get threads.
Yeah. So where does it get the material, from the end of the tube?
No, it's from the melt. It's from where it melts it.
It doesn't drill anything out. That drill is just a point. It's pure friction. It heats up red hot and pushes all that molten metal down in the hole.
Wow. And they actually make
it all displaces to the sides.
they make two different styles. They make one that's flush, and they make one that will leave a little lip on the outside of it too.
Yeah, mine's got a little funnel. McMaster's got the drills.
Yeah.
Yep.
I did some research into it. They're pretty dang cool.
It is pretty neat.
Yep. Well, guys, our hour is up. So look forward to seeing y'all next week. And if y'all have
Absolutely.
any thoughts or ideas, send them to me.
Thanks for coming,
Count
everybody.
me in.
Hey, everyone. Thanks for watching.
All right.
Bye.
Cheers.
Nice seeing everybody.
Talk
Nice
to
seeing
you.
all the new faces.
Thank you. Take care.
Yep.
Bye.